Welcome to our YouTube channel. In this video, we are going to talk about the introduction in chemistry. What is chemistry? What is chemistry? So, what is chemistry? It is very important for us to know what chemistry is, because if we don't know the definition for chemistry, then it will be something which is so hard for us to understand chemistry. In this case, we define chemistry as a study. Chemistry is the study of matter. So it is the study of matter and its properties, it undergoes under different conditions. So, from the definition of chemistry, we can see that we have a key word which is matter. We have a key word which is matter, which means when we know what matter is, when we know the properties of matter, and we know the changes it undergoes under different conditions, then we know what chemistry is. Matter is anything or any substance that has mass and occupies space. This space is also known as the volume. So the space is also known as the volume. Now, since we have known that matter is anything or any substance that has mass and it occupies space, it is very important to know that this matter is made up of some particles. We say there are 3 particles of matter. And what are these particles? So, number 1, we have got atoms. We also have got ions. Apart from ions, we also have molecules. When we look here, we see atoms. We know that for us to have ions, we need to make an atom to gain or lose some electrons. So when an atom gains or loses electrons, then it becomes an ion. But what is an atom? So an atom is a smallest particle of an element. It is the smallest particle of an element which takes part in a chemical reaction. So, this is a charged particle of matter. Now, coming to a molecule of atoms which are bonded together. So, we say a molecule is just a combination of atoms. Anything is made up of atoms. Because out of atoms, we have ions, have molecules. So it is very important that we know what an atom is. On the board, it is the structure of an atom. We have positively charged particles. These positively charged particles are found in the nucleus of an atom. These positively charged particles are known as the protons. They are called protons. Then, apart from finding protons in the nucleus, we also have other particles which are not charged, which means those particles are neutral. From the word neutral, they are known as the neutrons. So we have neutrons. So those which are not charged are called neutrons. Then we have these lines which are surrounding the nucleus. These lines are called the energy levels or orbits or orbitals. So energy levels. Now, within the energy levels, we find the electrons which are moving around the nucleus. You find that if in the nucleus we have 3 protons, it means that in the shells we are going to have 3 electrons also. So we can put an electron here, we put 1, then we come here, we also put another one here. Now, the first energy level just after the nucleus will only have the maximum number of 2 electrons. But according to the number of protons, we must have 3 electrons. Therefore, the remaining electron will go or will jump into another shell, which is the second shell here. So we can put it here. These are electrons. So negatively charged particles are called the electrons. Electrons. The mass for protons is 1. The neutrons is 1. Then for electrons, the number or the mass is 1 over 1840. These values are very important. So those are the masses. Then apart from that, we have already seen that the proton is positively charged, the neutron is not charged, then the electrons are negatively charged. From what we have here, it is very important for us to know, to say, since we say an atom is the one which takes part in the chemical reaction, hence electrons which are moving around the nucleus are the ones which are responsible to cause the actual reaction. We will talk much about how the chemical reactions occurs as we'll be talking about bonding. So, this is the atomic structure. It's very important. Note that the number of protons, so I'll just use the signs, number of protons to a neutral charged atom must be equal to the number of what? Electrons. Examples of atoms. So, examples of atoms, they are not even difficult to find because we know that atoms are found in elements. And the name of an atom is the name of an element. Therefore, we just say examples of atoms can be hydrogen. Apart from hydrogen, we have helium. Apart from helium, we can put magnesium. Apart from magnesium, we can put oxygen, nitrogen, argon, and many more. So those are examples of what? Atoms. What are the questions are we likely to have from the atomic structure? So the questions that we are likely to have, number 1 is, maybe they give you to say an atom had 6 protons. How many number of electrons were there? Now we know that any neutral charged atom will have the same number of electrons as protons. Therefore, the number of electrons for 6 protons will be also 6. Let's assume that if this is our oxygen, then we have got a small number which is down here. Then we also have a big number which is up there. So a small number for oxygen which is down here is 8. And what is on top here is 16. What we must know is the number which is down here, or the smaller number, will represent the number of protons. Hence, it will be called the proton number. Then, the number which is on top here is the sum of protons and neutrons. Which means, when we add the number of neutrons and the protons, we are going to get this number. And what do we call this number? This number is called the relative relative atomic mass, which is represented by AR. This number will be appreciated more under more concept. As for now, we just have to know to say this number is the sum of neutrons and the protons. Very important. So let us look at the states of matter. So now, usually there are a number of states of matter, but in this video we are just going to concentrate much on solids, liquids, and the gases. So solid, liquid, gas. These are the three states of matter that we are going to concentrate much on in this video. To make things simple, I am going to make a table which will help us to remember these things. So we have the solid, liquid, and the gas this side. Solid, liquid, and the gas. Number one, we need to know about the arrangement of particles in these states of matter. So we'll say arrangement of particles. How are the particles arranged in solids? In solids, particles are closely packed. They are closely packed. In liquids, they are a bit far away from each other. So in liquids, they are a bit far away from each other, which means they are not as compacted as in solids. So we can just say they are further apart. They are further apart from each other. We are talking about the arrangement of particles. Then for the gases, you will find that particles are very far away from each other. Very far away from each other. So we say very far away from each other. Very far away from each other. Very far away from each other. Now, apart from that, we need to also consider the diagram. Let's say if we have this diagram which represents the solid, they are closely packed. Closely packed. Then, coming to liquids, in liquids you find that they are a bit far away from each other. They are a bit far away from each other. Coming to gases, you find that they are very far away from each other. Very far away from each other. Now, a question can come just using the diagram to say, identify the state of an object on the diagram, which means we must be able to identify that this one which has got particles which are closely packed is a solid, this one is a liquid, and this one is a gas. Let us look at the movements of particles. How are the movements? You will find that in solids, particles will just vibrate in their fixed position. Now, what do we mean when we say they are vibrating just on their fixed positions? You can see that, let's assume that this particle is trying to move. Because there is no any space in this direction, or this direction, or this direction, it will just be shaking on the same position. We come to the liquids. The particles can move from one point to another. Particles can move from one point to another. They easily move because there are some spaces. There are some spaces. You can see that there is some spaces. So this object, or I mean this particle, can move from here up to somewhere just like that. They move from one position to another. We come to this. You find that these particles in gases, they move from one place to another. They don't have any direction. no any direction. So they form a zigzag movement. And that one was discovered by Braun, and he named it as the Brownian motion. They move from one place to another. How is the shape of solids? So for solids, you find that the shape, they have a definite shape. They have a definite shape. So they have a definite shape. This one, these guys, which are called the solid, are liquids. They don't have shape. They just follow the shape of the container. So they follow the shape of a container. So they follow the shape of the container. They follow the shape of the container. Then these also follow the shape of the container. Although they move from one direction to another, so they also follow the shape of the container. Yeah. Then, apart from that, you find that we also have another character. And what character is that? The character we have is, how are the forces? You find that the forces which are between the particles of the same substance are called the cohesion force. Cohesion force. Now, the forces which are in solid particles are very strong. So they have strong cohesion forces. Then these will have weak cohesion force. Then these will have weaker or no cohesion force. Then we proceed to the volume. So the solids have a fixed volume. Then liquids, okay, so before we talk about liquids, these will fill, they fill all the spaces available. They fill all the spaces available. Then this, the volume is also fixed, so they have a fixed volume also. They have a fixed volume. Then, after that, we look at the compressibility. Are they compressible or not? Okay, so these solids are non-compressible. They are non-compressible. You can't compress these solids. Liquids are slightly compressible. They are slightly compressible. Coming to the gases, these are compressible. These are compressible. Alright, now, after looking at the state of matter, let's see the changes of states of matter. Changes of the states of matter. Changes of the states of matter. Now, what are the changes? Alright, let's say we have a solid here, we have a liquid here, we also have a gas here. Alright, this solid can change from its solid state to liquid state. Then the liquid can change from its liquid state to gaseous state. This gas can change from it being a gas to a liquid, from liquid back to solid. Or the solid can change directly to gases, then the gas can change directly to the solid. Let's assume that we have a change which occurs from solid to liquid. This one is called the melting. This one is called the melting. Then the temperature at which a solid changes to liquid is called the melting point. From liquid, it can change to what? To gas. This change is called the evaporation. The change from gas to liquid. So this one is called the condensation. Change from liquid to solid. This one is called the solidification. Let's get an example of water. We get an example of water. So solidification can be also called the freezing. Yeah, freezing. And the temperature is called the freezing point. We get an example of water. If it was water, water would exist in solid form as the ice. Then from ice, it can change or it can melt to liquid, which means now it will be called the water. Then, from it being water, when it becomes a gas, we say it is the water vapor. This is water vapor. Okay, so ice, water vapor. So this one is in solid form, this one liquid, then this one is in a gaseous state. So the change from ice to water is called melting. The change from water to water vapor is called evaporation. And this temperature is called the boiling point. The boiling point. So this is the boiling point. Then, apart from that, this water vapor can be condensed or changed from its vapor state to water by means of reducing the temperature. So, what is happening here is, for a solid to change from its solid state to liquid state, it means that the forces which are in solid particles have been reduced. And for these forces to reduce, it means that the temperature has to be increased, which is going to weaken the forces between the particles. And when the forces are weakened, it means that the particles in the solids are no longer compacted as the way they was, because they were held by cohesion forces. So they will become weak, which means the change from solid to liquid gains heat. And the change from liquid to gas also gains heat. Then from gas to liquid loses heat, and from liquid to gas also loses heat. Because a question can come to ask you to say which one of the following involves the gaining of energy in form of heat. So the correct answer is the change from solid to liquid, or the change from liquid to gas. Then the one which requires the loss of energy, we have gas to liquid, then liquid to solid. So these are the important things that we have to know. Apart from that, the direct change. From solid direct to gas, this one is called the sublimation. Sublimation. Then we also have that change which occurs from gas to solid. From gas to solid. So this one, in some old books, they can say it is also known as sublimation. But we can say the change from gas to solid is called the deposition. So this one is the deposition. This one is the deposition. So examples of substances which can sublime, or substances which can change from solid direct to gas, or from gas direct to solid. We can get an example of What example? Very good. So it is iodine. So this question usually comes to say, give one example of a substance which can undergo sublimation. So the correct answer is iodine. It's very important to know about that. Now, how are the questions phrased out of this? So you find that they can use letters. They use letters, then they say maybe this is A, B, C, D, E, F. Then they say, what do we call the process labeled A? So we need to know this diagram by heart, so that even if a question was to come, we can be able to answer it. Now, sometimes they just draw diagrams here. Instead of writing solid, they just put the diagram for the solid. Here they put the diagram for a liquid. Here they put the diagram for the gas. So we don't need any confusions there. Otherwise, thank you for watching this video. Don't forget to hit the like button and subscribe to our channel. For more details, please, you can reach us through +26 0779 489 211. Thank you so much.